So basically, so far, we've learned that if the bottom is the same, we can just combine the tops and we can just get an answer. And the same thing happens with subtracting. As long as the denominator, the thing on the bottom, is the same, then we can just combine what's on the top. So this first example, they've already done it for us. The bottom is 5. So the 5 just carries over. You don't change the denominator. But then you just add 2x minus 3x and you get negative x. Okay? Let's do a few of these that just have numbers and then we'll go to the x's. So on this one, the bottom is 8. So I just leave it as 8. And then I do 6 minus 3, which is 3. And so adding and subtracting, as long as the denominators are the same, are not a huge deal. Looking at number 3, the bottoms are already the same. It's subtracting, so I do 12 minus 5, which is 7. So even though there was an x, that really didn't change anything. Okay? On the next one, the bottoms are the same, the denominators are the same, so we've got 15, and then we're going to do 2 minus 11. Now, whenever you get problems like this where there might be just numbers, you should try to simplify if there's anything to simplify, which there is in this case because I can divide everything by 3. And so I would get negative 3 over 5. I do want to remind you, you could put negative 9 over 15 into Desmos and hit the fraction button. Since there's no x's, you can do that. Number 5. The bottom is just 4. We want to subtract here. They're not like terms. So that just means that we're going to put x minus 5 like that. So x minus 5 and then over 4. On number 6, again the bottoms are 9, the denominators is the same. And then we want to subtract. These are like terms. It's not like the x and 5 and number 5. They are like terms, so I do want to combine them. 2x minus 4x. And I get negative 2x. Whenever you add or subtract with the x's, you keep the x and then you add or subtract the coefficients. Number 7. The denominator is x plus 5, so I know that's going to be an x plus 5, so then I worry about the top. 8 minus 5 is just 3, and then I'll leave it, nothing to do. Number 8. The bottom is 4x, so it'll just stay 4x. I have a 9 and a 3x. The 9 and the 3x are not like terms, so I don't combine them, but I do just put 9 minus 3x. I'm going to skip to number 10 real quick. Let me show you that one. So on the bottom, I know that's going to be a 6, but here I'm going to subtract. It says x plus 5 minus x. So what that means is that the x's are like terms. One of them's a 1 and one of them's a negative 1, so it's pretty much I'm just getting rid of that x, which means I'm left with just 5 over 6. Whenever you're subtracting the x, you're getting rid of that one, and so all you're left with is a 5. Okay, on number 9, so the denominator is just going to be x plus y. This has a minus in between it, so that means I'm going to subtract it, which means I'm going to have x minus y, and they didn't combine because it was an x and a y. And then nothing cancels or get rid of anything because we've got pluses and minuses and it's not the same. So I just leave it just like that. On the next one, 9 is the denominator. So it says x plus 3 minus 4. So the x isn't going to combine with anything, so it's just an x, but I do need to take 3 and subtract 4, which means we'll have x minus 1 over 9. Number 12, x is your denominator. Here we're going to take x plus 4 and subtract 4. So when I subtract 4, the 4's, that just means that goes away. All we're left with is that x. And this is a problem that when you end up with something like that, x over x, you can get rid of everything because everything is the same. And when everything goes away like that and you simplify, you get 1. So x over x equals 1. Alright, so let's look at a little bit more complicated ones based on what happens whenever we're subtracting. So 13, they've already done this one for us. The denominator was 2, but it was a subtracting problem. And what they did is they changed both of the signs after it. See, whenever, all the ones we've done so far, it's just been one thing that was subtracted off. But when there's 2 things subtracted off, you have to think about subtracting both parts. So what I think is easier is change it to plus and then change everything afterwards. So on number 14, it's a minus right there, so I'm going to change that to plus. That x I'm going to change to a negative, and the negative 2 I'm going to change to a positive. So I changed everything after it, and now I combine and try to figure it out. So the denominator is still going to be x. But then when I look at the numerator, I'm going to take 2x and subtract x. 2 minus 1 pretty much. So that just gives me an x. So I'm combining like terms. Then I have a 1 and a positive 2, which gives me 3. Nothing goes away because I can't get rid of those x's because the plus 3 is there, and then that's the answer. So when you're subtracting, if there's more than one thing that's subtracted after it, you have to think about changing both of those signs. So on number 15, I see how x plus 1 will be on the bottom, but I'm subtracting and there's 2 things to subtract. So I'm going to change that to a plus, and I'm going to change the signs of everything after it. So I'll take 6x minus 2x, which is 4x. And then the only other number left is that 3, but it's a negative because I changed it. So it would be minus 3. So 4x minus 3 over x plus 1. Okay, for number 16, so on the bottom we know there's going to be a 2r. Okay, so here we've got a minus and 2 things after it, so I'm going to change that to a plus and change both of the signs after it. So I'll have 3r minus 3r. So that's 0 r's, so no r's will be there. 1 plus 1, so that'll be 2. 2 over 2r. And then because everything is just multiplied, I can reduce these 2's and make it 1 over 1r or 1 over r. Number 17. Again, I know that the bottom is going to be a minus 2. We're going to change this to plus and change the signs after it. So a plus negative 2a is negative 1a, or negative a. 4 plus 6 is 10. So once we change those signs, we're just changing it to adding, and we're just adding those terms, whatever they are. On 18, I know that that's going to be an x plus 3 on the bottom. That's a plus, negative, and then plus. So there's no x squareds to combine with anything, so x squared comes first. This is the only x, so that'll just come next. And then we have negative 5 plus 5, which is just 0, so there's no numbers. So just x squared minus x over x plus 3. We'll do this last one on this side together. I know that 2x will be on the bottom. Minus, and a whole bunch of things were minus, and I'm going to change that to plus and change every sign. So x squared minus x squared is 0. That won't be there. 3x plus 5x is 8x. Negative 1 minus 2 is -3, and then that's what you get for your answer. Okay, so when the denominators are different, what we have to do first is to figure out what the common denominator is going to be, and then work it out from there. So I have to make the denominators the same. Okay, we're going to work out some of the ones on this column and then go from there. They've sort of already started one for you, but I'm just going to start with 31 so we can see it fresh. So start off with the denominator. So we have a 7 and an 8, and we're trying to find something that both 7 and 8 go into. A lot of times if you multiply that together, that will give you a common denominator that you want. Basically what's going to happen, especially when there's a bunch of x's and y's, I'm going to take whatever this denominator is and multiply it here, and whatever this denominator is, I'm going to multiply it there. Because when I do that, that makes two denominators that are the same. See, 8 times 7 is 56, 8 times 7 is 56, so I've made the denominators the same. But if I do that on the bottom, I have to also do it on the top because I don't want to change the problem. So if I multiply that by 8, I also have to multiply that by 8. If I multiply this one by 7, I have to multiply this one by 7. Alright, I know the bottom is going to be 8 times 7 because that's what they both are, and that's 56. So on the top, I'm going to have 8 times 4, which is 32, minus, and then 1 times 7. Because these were all numbers, I can go ahead and subtract that. If there were some x's there, you might not be able to do that. But I'm going to take 32 minus 7, which I think is 25. And then that's my answer. So the next one has x's in it, so let's see how that works. So we have 5 and 4. So our common denominator is going to be 5 times 4, 20. Which really means I'm going to multiply the 4 times 5, which means the top has to be multiplied by 5. And I'm going to multiply the 5 times 4, which means I'm going to multiply the top by 4. So basically you're just multiplying the opposite one by itself. Alright, on the bottom, 4 times 5 on both of them is going to be 20. 4 times 2x, so you multiply the numbers and leave the x, so that would be 8x. X times 5 is 5x. And after you figure that out, then go one more step and combine it if it can be combined. 8x minus 5x is common factors, so I can go ahead and do that, and I get 3x and then 20. So you really don't change the bottom after you figure out what the bottom is going to be. Skip on down to 37 because it's got some x's and y's there. Alright, I'm going to multiply this one by 2y, which means I need to multiply the top by 2y. I'm going to multiply the 2y by x, which means I'm going to multiply the top by x. So that means that my common denominator is going to be the 2y and the x all put together, 2xy. 2y times 4 is 8y. 3 times x is 3x. And so there's what you get for that one. And then there's nothing to do because you've got a y and an x and you can't combine those. Okay, let's keep going. So we've got a 5 and an x as our denominator. So I'm going to multiply the 5 by x, which means I also need to multiply the top by x. I'm going to multiply the x by 5, which means I need to multiply the top by 5. That means my common denominator is the 5 and the x multiplied, so 5x. Alright, 3x times x is 3x squared. 4 times 5 is 20. And so you get that. Alright, on 34, y and x are going to be our two denominators, so I need to multiply the y times x and the 7 times x. I'm going to multiply that by y, which means the 5 is multiplied by y, so we'll have an xy on the bottom, and that means that 7x plus 5y will be the top. And I do not combine those because those are not like terms. On 36, we've got the a and the b. That means this one needs a b, so the top needs a b. The b needs an a, which means the top needs an a. So that would be 7b plus 3a over the bottom, which is just ab or ba. On 38, we're going to multiply the 3 times 5, which means the x has got to be multiplied by 5. We need to multiply the 5 by 3, which means the 4 has got to be multiplied by 3. So on the bottom, that's going to give us a 15, because 3 times 5 is 15. X times 5 is 5x. 4 times 3 is 12. And so we get that answer. On number 40, the x is needing a y, and the y is needing an x. If I put a y there, got to put a y there. Put an x there, got to put an x there. Same thing on bottom and top. So on the top you would have 8y minus 7x. On the bottom you would have x, y. Now, I'm going to skip on down and show you one other one that looks kind of complicated, number 45. So I want to talk to you about that one just a second. We've got lots of things on the bottom. We've got a 5y and a 3x. What that means is that the 5 and the y and the 3 and the x all need to be there. So I'm going to have to multiply this one by 3x on both of them. And I'm going to have to multiply this one by 5y on both of them. So on the bottom, what that means is you'll have 15 because 3 times 5 is 15. And then xy. And then on the top, when I multiply here, I multiply the 3 and the 3. And then when I multiply the x's, that gives me x squared. Over here, the 5's, when I multiply the 5's, that's 25. And then the y's, when I put that together, that makes y squared. I just wanted you to see that one because it just has more stuff with it and it looks a little more complicated. I think the rest of those that we skipped are pretty much the same. Just wanted you to see that one. Alright, we're going to continue very quickly with what happens with common denominators when the common denominators are not quite so simple. Okay? They've done an example for us up at the top, and I realized that 7 and x plus 5 together must be the denominator. And so what that means is that this one's going to have to multiply by an x plus 5, and this one's going to have to multiply by a 7. When you do that, you're going to end up with this. And you just combine those. This part that has the hole cut out of it, just so you know, is a 3x squared plus 15x over 7 times x plus 5. That way that's not marked out for you. So let's do one of those together and talk about how that works out. So on 50, 8 and a minus 2 are going to be what I want the common denominators to be. I know it's going to be 8 and then a parentheses a minus 2. That's going to be the denominator. Alright, what that means is that the 8 has to be multiplied by the a minus 2. And the a minus 2 has to be multiplied by 8. Okay? If I do it on the bottom, I go do it on the top. And this is where it's just a tad bit tricky. You see how you have a 3 on the top there with the a minus 2? I have to multiply 3 times a and also 3 times 2. Kind of like the distributive property. Okay? So 3 times a is 3a. 3 times 2 is negative 6. And then we're minusing whatever we get when we do 5 times 8. 5 times 8 is 40, so we're going to subtract 40. Alright, the bottom is going to stay 8, and then a minus 2. The top, there's being 3a, but then you combine that negative 6 and negative 40, and make it negative 46. So the tricky part is whenever part of your denominator is something like a minus 2 or x plus 5, if there's something to multiply by it, you have to use the distributive property and multiply each thing by each thing. Okay? There's another one just like that on 51. So my denominator is going to be both of these two things put together. So I'm going to multiply the first one by 4x, which means the top has to be multiplied by 4x. I'm going to multiply the 4x by x plus 2, which means the top has to be multiplied by x plus 2. Alright, the 4x times the 5 is going to make 20x. And then plus, and then the 3 has to multiply by the x and the 2. So that would be plus 3x plus 6 over, and then your 4x and your x plus 2. And then you're not finished, because we want to combine those, so we get 23x plus 6 over 4x times x plus 2. So on 52, we've got this x plus 1 and the 5x. So I'm going to multiply that by 5x, which means I also need to multiply the 2 by 5x. The 5x will have to be multiplied by x plus 1, which means the 2 will have to be multiplied by x plus 1. So on the bottom, I know I'll have a 5x and an x plus 1. Alright, 2 times 5x is 10x. And then the 2 has to be multiplied by the x and also the 1. So that would be 2x plus 2. And then combine if there's anything to combine, and there is, because the 10x and the 2x makes 12x, plus 2, because that's what's left over 5x, and then x plus 1. We're going to do 2 more, I think, and then stop. So on number 53, this one's just a tad bit harder because these two denominators are both binomials. I need to multiply that by x plus 1, which also means I multiply the top by x minus 1. X plus 1, I'm sorry. This one has to be multiplied by x plus 3, which means the top has to be multiplied by x plus 3. So let's talk about how that's a little different from what we just did. The difference is that we've got x plus 1 times x minus 1. We have to use FOIL or the distributive property or multiplication, however you want to think about it. Everything has to be multiplied by everything. So like x has to be multiplied by x, which is x squared. X has to be multiplied by negative 1, which is negative x. And then the 1 needs to be multiplied by both things. So 1 times x is 1x. And then 1 times negative 1 is negative 1. So it's like 4 things that have to be multiplied when you have binomials together like that. And then on this one, the 2 will multiply by x, and the 2 will multiply by 3. So that would be 2x plus 6. And then you combine anything that can combine. So x squared is the only x squared that I see. Alright, negative x and x is 0, and then there's another 2x, so there's a 2x. And then there's a negative 1 and a 6, which makes a 5. So the only reason that one was a little different is just because there were more things having to be multiplied whenever you multiply this part right here. Okay? I'm going to do one more like that, where there's more things to multiply, and then we'll stop and You'll have time to practice. So, x and x plus 3. So this one's going to have to multiply by x plus 3, which means the top one also has to multiply by x plus 3. This one has to multiply by x, which means the top has to multiply by x. Alright, when I do x plus 3 and x plus 4 together, I'm thinking about multiplying each little thing. So x multiplies by x multiplies by 4, 3 multiplies by x, and 3 multiplies by 4. Then the two x's can combine, so that's a negative x squared. And then on the bottom, we just have an x and then an x plus 3. Alright, we can combine some things on top. The x squared and minus x squared goes away, that's 0. The 4x and the 3x makes 7x. And then we've got a 12. And then x plus 3.